All right, so complex numbers revolve around this question. What is square root of -1? The square roots are normally like pretty straightforward, like square root of 25 is 5 times 5. Square root of 16 is 4 times 4. The problem here is there's not a number that times itself is -1. It's like 1 times 1 is +1, and -1 times -1 is also +1. But I can write this, so it's got to be possible. And that confused math dudes for a long time. So, in order to solve it, they invented a new number, and that is the imaginary unit. The imaginary unit, and it looks like this. It's a kind of a cursive I or a scripted I. And that's the reason you couldn't use I when you were doing algebra variables. So the way this works is that the square root of -1 is the same as this I, but also if I take I and I square it, my answer is -1. And that's really all there is to imaginary numbers. It gets a little bit complicated when we put an imaginary number with a regular number. So if I take a imaginary and a regular number and put them together, it makes a complex number. So complex is I've got like some number A plus some other number B that's imaginary. That's all it really means. All right, so what's this stuff going to look like? So let's say that I gave you a problem and I said, hey, what is, I don't know, the square root of -24? All right, well, the square root of 24, that's 6 times 4, right? So the 6 isn't a perfect square. The 4 is a perfect square, so a 2 comes out, and the negative means I get an I at the end. So it's just like when we were doing radicals before, except you throw an I to mean that there was a negative in there. Super easy. So if I had maybe, I don't know, 3 roots of -27. Okay, so the square root of 20, so 27 is 9 times 3, so a 3 comes out. 3 times 3 is 9 now. And I've still got a 3 in the house. The negative means I put an I on there. I's are pretty easy. The only thing that I keep doing, and I don't know if you've noticed, is this form is important. So the I goes at the end. That's the only kind of weird part. If I was going to graph it, and I'm not going to make you graph it, I just want you to know that you can, straight up. If I was going to make you graph it, like you know how normally we get a graph and it's X and it's Y, and you plot the points super easy? If I was going to be doing imaginary numbers, X stays where it is, and the vertical axis becomes the I axis. So if I had the point like 3 comma 2I, I'd go 1, 2, 3, and then up 1, 2, and this would be the point. That's all it is. We are not going to do any graphing of complex numbers, so I'm not super worried about it. But I did want you to know that it is something you can do. Like there's nothing weird about it. When we're solving stuff later and we get a complex number, that just means that our point is up here. It's floating above our x-axis for our solutions. So we will get there. What I want to do with them complex numbers today is I'm going to write something that looks absolutely terrifying. Okay, it's going to look terrifying, and I'm going to show you it's ridiculously easy, which is probably my favorite thing to do. So we're going to be adding complex numbers. Adding's easy, right? 1 plus 1 is 2. It's that hard. We add them like we do binomials. So if I have a plus bi, this is where I said it's going to look scary. plus c plus di. My answer is going to be a plus c plus b plus d I. Still complicated because that's the look I had the first time I saw this. All right, are you ready to see how stupid easy this is? Because this looks really complicated. Watch this. If let's put some numbers in it. Watch this. 3 plus 2i plus 1 plus 7i. What these instructions up here say to do is add the regular numbers. What's 3 plus 1? Done. Then we're going to add the i's. 2 plus 7. There's my answer. Yeah, that's all you have to do. Mm-hmm. So subtracting works the same way. So it's the same rule here, except instead of pluses, these are minuses, right? So the only thing that's a little bit weird about subtraction, if it's a minus bi or a plus bi minus c plus di, it'll be a minus c plus b minus d. So let's do a subtracticin. Subtracticy one. Why can't I say subtracty one? My mouth is not working properly. So let's do 8 plus 6i minus 5 plus 2i. So what I'm going to do is I'm going to say 8 minus 5 is 3, and then 6 minus 2, 4i, and done. The only time that this gets kind of, like to me, the only time this gets kind of sucky is when we end up with the problem having like -8 minus 6i, you end up with integers in there. That's the only time that I ever have to like stop and really go, wait a minute. So really, we're taking the whole numbers, like the regular numbers, and doing whatever this operator says, and then we're taking the I numbers and doing whatever this operator says, and then we're done.